Time to get started with learning about pharmacology. So chapter 1 is Introduction to Pharmacology. In your textbook, you will see the learning objectives, as they are also shown here on this slide. We're going to start off by talking about medicinal uses for drugs. To get started, let's talk about some general terminology. Pharmacology, simple definition, is the study of drugs. Pharma, meaning drug, ology, meaning study of. Now, drug is also a word for medicine, and the word medicine comes from the Latin medicina, which means remedy or cure. It refers to drug administration for its values. Generally, we have 3 different types of uses for medicinal drugs. We have therapeutic use, which will treat a disease. Basically, it's to control, improve, or cure symptoms or signs of a disease. An example of a therapeutic use of a drug would be an analgesic. Anal, A-N, means without, and gesia is pain. So an analgesic is used to treat pain. We also use drugs to reduce inflammation. We use antibiotics to treat an infection. And we use drugs to do things like lower cholesterol or lower your blood pressure. Those are all therapeutic uses. A second indication of a drug is prophylaxis. This means to prevent a disease. Prophylaxis comes from a Greek word which means to guard before. So if you've ever gotten sick on a boat, or if you have motion sickness when you're in the car, maybe you took something like Dramamine or Bonine before you went into the vehicle. That would prevent nausea. That would be prophylaxis. Also, something like an oral contraceptive would prevent the condition of pregnancy. Often, vaccines are used to prevent or as prophylaxis to illness. The third and less common use of a drug is diagnostic. These mean that we use drugs to help diagnose when there is a disease. It could be used alone, like giving a hormone to see how the body responds, or sometimes we give a drug to increase the heart rate. If someone cannot physically do a stress test on a treadmill, we can increase their heart rate to mimic that exercise to find out their cardiac health. We can also use drugs diagnostically along with x-rays or other laboratory tests. So contrast dye could be used in an x-ray or an MRI. So therapeutic is the most common use, prophylactic, and then diagnostic. Now, just a little bit of history. So we're going to start in the 1700s. So we're starting there because that's really when we start coming into kind of the progression of medicine through our history. So again, some terminology. So apothecary. It's actually from a Greek word that means storehouse, and generally was where they stored plants or herbs. Back in the old days, that's what they made medicine from. So an apothecary could be actually a building like a pharmacy, or an apothecary is also sometimes used for the pharmacist. Now, compounding is actually when drugs are being made. So they're prepared according to a standardized formula, which is basically a recipe, and it could be, in the old days, again, those dried plants or herbs, but for us it could be grinding or mixing of ingredients. There are several compounding pharmacies in the New Orleans region. Now, the term pharmacopoeia looks a little weird, and I know we don't have books like we used to, but encyclopedia kind of is along the same lines. This is kind of a listing of drugs, where an encyclopedia is kind of a listing of information. So a pharmacopoeia is a listing of drugs. Now, it gives all the drugs used in pharmacy, including ingredients, strengths, impurities, and how to prepare them. Now, in the United States, we have what's called the USP, or the United States Pharmacopoeia, which was first published in 1820. The very first pharmacopoeia was in Germany in the 1600s. Moving into the 1700s here in the United States, this is when pharmacy really started kind of being the precursor of what it is today. So in 1729, the first community pharmacy or apothecary shop was opened in Philadelphia. In 1751, the first hospital pharmacy was being built in Philadelphia as well, and it opened in 1752. This image on the screen is a rendering that depicts what that pharmacy may have looked like in 1752. So we see our pharmacist here. He was the first hospital pharmacist, and his name is escaping me right now, but he's using a mortar and pestle, and he's grinding his ingredients. And back here we see some apothecary jars. They would have ingredients in them. We've got some jars over here. And we see over on this side, the physician is in the ward overlooking his patients. Interesting fact, if you like trivia or historical references, Benjamin Franklin was the person who built that first hospital and hospital pharmacy in Philadelphia. Now, there is a connection to pharmacy in Louisiana, and it started in the 1800s. So in the early 1800s, there weren't any regulations on pharmaceutical standards or anything in the whole U.S. A person could just apprentice in the field of pharmacy for 6 months, and then they could go out and they could open their own apothecary shop. Now, in 1804, the governor of Louisiana, before Louisiana was even a state, realized the problem and established a board of medical professionals to conduct licensing examinations. In 1808, the board rejected apprenticeships. So it said, nope, you can't learn on the job anymore. You have to go to school. It made it mandatory for the students to rely only on a college education. So Louisiana was the first state to require education for pharmacists. The first registered pharmacist also came from Louisiana. His name is Louis DeFilo Jr., and his pharmacy or apothecary was on Charter Street. At the time, it was noted as 63 Charter Street, but they've renumbered the whole French Quarter. So his shop, they now have an apothecary museum on the location. Now, his original one burned down probably twice with fires in the 1800s, but the Louisiana Pharmacy Museum, which we see pictured here down at the bottom, is at 514 Charter Street. Now, Mr. DeFilo went to France. He went to college, he trained, he took an examination in 1816 in France, came back to the United States. He was the first registered pharmacist in the state of Louisiana in 1823. Now, today's pharmacy, we have a number of different types of pharmacies. The most common is going to be your community pharmacy, like your Walgreens and your CVS, or your hospital pharmacies. Now, a hospital pharmacy, sometimes referred to as an inpatient pharmacy, is in a hospital. Generally, it's going to have one large area that's known as the central pharmacy, and that's where medications are distributed, get that word out, distributed, and that's also where orders are verified by pharmacists, IVs may be made by the technician. There's a whole lot going on in a central pharmacy. Unless you work in pharmacy, most people never see what's happening behind the doors in a hospital pharmacy, in the central pharmacy. Now, a hospital may also have a satellite pharmacy, which means maybe in the emergency room or the OR or in a nursing unit, there may also be another pharmacy. It's going to have much less inventory, staffed by a pharmacist. ICU is another place where sometimes we'll see a satellite pharmacy. Now, when we're talking about institutions or clinics, we may also have an outpatient pharmacy associated with a hospital or a clinic. Those are usually referred to as an ambulatory pharmacy. So when the patient goes to leave those places, ambulatory means being able to walk. So they can pick up their medications as they're leaving. Skilled nursing facilities, something like a nursing home type place or a long-term care facility like a rehabilitation. If somebody's had a stroke, they may go to a skilled nursing facility to recover. They don't need to be in the hospital anymore, but they're not ready to go home. And they're not actually going into a nursing home. So those are your main types of healthcare facilities, pharmacies that are associated with hospitals, clinics, or healthcare groups. Now, a community pharmacy, that's usually referred to as a retail pharmacy. And like I said before, that's your Walgreens or your CVS. So those are kind of the big chains that we know. But here in Louisiana, we also have a lot of independent pharmacies. So you have a pharmacist owner, or they might own one store, maybe two or even three. Patio drugs, car drugs, CNC. There's a number of different community pharmacies that are independents here in Louisiana. There's also an area of community pharmacy known as a closed-door pharmacy. Now, a closed-door pharmacy, a patient can't walk in with a prescription. They only get prescriptions electronically or through fax, and then the medication gets delivered. Now, that may be accommodating a skilled nursing facility or a nursing home, but nobody comes in off the street for that. In a closed-door pharmacy, not only might they be dispensing prescription medications, but they might also be making intravenous admixtures or medications, including antibiotics, chemotherapy, or nutritional support. Now, an online pharmacy, these have become more prevalent. Even Amazon has a way to order medication from an online pharmacy. There are some restrictions. We want to make sure that they're reputable. Where your other pharmacies are licensed by your state board of pharmacy, an online pharmacy is not usually in the state. It's a central location somewhere else. So online pharmacies are accredited, and they are accredited by the National Association of Boards of Pharmacy, which is known as the NABP. Now, one of the types of retail pharmacies, but we also do this in hospital, is a compounding pharmacy. So in this image, we see two people here. The one in the long coat is probably the pharmacist, and the one in the short coat may be a technician. So what they're doing is they're mixing using, again, that mortar and pestle we saw in that other slide with that early pharmacy, where they're mixing the ingredients, which are all stocked up here. We've got lots of glassware for measurement. They have a powder hood over here so that chemicals don't blow into the air. And then there's going to be a scale. There's lots of measuring and weighing. Now, when we have this type of compounding, it's known as extemporaneous compounding. That means that it's extra. It's for a specific patient. It's something that's not commercially available. So the patient maybe the drug's not available, or it's not in a dose form that they can take if it is commercially available, or maybe we need a smaller dose for a child or something like that. So compounding is another area of pharmacy that's quite prevalent. We have a lot of compounding pharmacies here in Louisiana. Now, the next section talks about technology in pharmacy. Now, I think of this not only in pharmacy, but healthcare in general. So the first one is barcode technology, and we use it in the pharmacy when we're scanning medications to make sure that the right thing is going into the patient profile. But here we see the image of the healthcare provider scanning the patient's wristband that has a barcode on it, and that helps us identify that we're giving the right medication to the right patient. And that's pretty important because medication safety is our first and last responsibility when it comes to any kind of health care. We want to make sure that we keep our patients safe. So barcode technology really can enhance that. Now, in pharmacy, we also use robotics. So robotics can help with making sure that things are done systematically. It can speed things up. Different types of robotics. We have some that will fill syringes. We'll put a big 3-liter bag and connect it and program it, and it'll just keep refilling syringes until the bag is empty. It just helps cut down on time and cost. We also use automated counting machines and things like that. Now, computerized transmission of prescriptions, that's known as e-prescribing. And that's good technology in helping keep people safe as well, because one of the challenges is doctors' handwriting. Generally, they're very busy, and it can be near impossible to read what they've written. It takes skill. It takes time to develop that. It's kind of like looking at a Where's Waldo poster and you finally, ooh, now I see what that word is. But if we have e-prescribing, it's coming through a computer, so we don't have to guess at what the handwriting is. So it helps, again, to cut down on medication errors and keep our patients safe. When we're talking about pharmacology and understanding the pharmacist and the pharmacy technician and their roles in pharmacy. So the pharmacist is a healthcare professional who manages a pharmacy and dispenses medications. They work in all different types of pharmacies. They provide personal assistance to the customers. They do consultations and counseling, and they do what's called medication therapy management. Now, in 2000, the requirement for completing a pharmacist requires them to do a PharmD. So this is a doctorate level. They do have the respect to be called doctor. It's a doctorate in pharmacy. Now, people prior to 2000 may have completed a Bachelor of Science in pharmacy, and they would be a registered pharmacist. They would be an RPH. They still exist out there. They're mostly at retirement age, but there are still some RPHs out there. The knowledge is very similar. The PharmD focused more on clinical knowledge, where the RPHs, they were still doing a lot of operations type things when they were learning business operations. Now, pharmacy technicians, their requirements can vary state to state. So every single state determines what's required to be a pharmacy technician. In the state of Louisiana, it requires the pharmacy technician to complete an accredited training program. Delgado has an accredited training program, and in fact, I'm the program director for that program. And then they have to sit for a national certification exam. And when they pass that exam, they receive the credentials of CPHT, which is a certified pharmacy technician. They complete their training at Delgado, they get their certification, and then they can register with the state of Louisiana as a pharmacy technician. Louisiana was one of the first states. We were one of the first 5 to require a test, and we were one of the first 5 to require education and accredited education. And like I said, our program is accredited, and we have been accredited since 2002. We were one of the first 3 programs in the state to be accredited. Now, when it comes to taking the certification exam, there are actually 2 exams that are recognized by the Louisiana Board of Pharmacy, and both will give the credentials of certified pharmacy technician. Now, what is a technician, or what do technicians do? Well, they support the pharmacist. They do everything that doesn't require clinical judgment. So the pharmacist is the one with that professional judgment, but we assist who performs pharmacy-related tasks under the pharmacist's direction. We fill prescriptions, we do labels, we stock shelves, we help customers, we work in hospitals, we make IVs, and then we have all sorts of new areas. We do point-of-care testing, we give vaccinations, we can work in clinical settings, we work with investigational drugs. So there's a lot of different things that pharmacy technicians can do. It's really expanded in the last 5 to 10 years and continues to evolve. So it's quite an open field. All right, now let's get back to the drugs themselves. So drug discovery and creation. So where do drugs come from? Well, basically, originally they came from natural sources. We've had listings of medications and treatments for over 3,500 years, going back to the Ebers Papyrus. So we didn't have chemicals and manufacturing plants like we do now, so everything came from nature. So plants, animals, and minerals, those were our original resources for producing medications. So when we talk about plants, the foxglove plant is very pretty. So this, we get a derivative of this plant to make the drug digoxin, which is known as lanoxin, and that's used for congestive heart failure. It helps the heart beat stronger. Now the poppy plant, opium can be produced from the poppy plant, Opium is used as a painkiller. It's also been used to produce the illegal street drug heroin. That also comes from the poppy plant. The source of the prescription drug morphine is saps from the blue-green seed head of the pink flower of the opium poppy. So a specific component of the opium poppy is where we get morphine from. Now, morphine's been available since 1806, and we still use it today. Another resource considered to be a plant is mold. So Penicillium chrysogenium. So penicillin gets derived from this mold. So if you've ever had an infection and they gave you penicillin, it actually came from a mold. Of course, it's been refined, and we use that drug to treat infections. Now, when it comes to animals, this is where it starts to get interesting. So the first thing here, this is called a Gila monster. So it's actually a lizard that lives in the southwest U.S. It's got this chemical in its saliva that got extracted. Who even knows where they came up with this, right? But they extract the saliva from the Gila monster, and they developed a drug called extenditide, which is Byetta. And this drug is actually used to help treat type 2 diabetes. Pretty cool. Thyroid, Armour thyroid. Whenever I hear this, my head goes to the song Armour Hot Dogs. So way back in the 18 and early 1900s, when they had slaughtering houses and they were processing pork and making hot dogs, they didn't want to waste anything. So they actually took the thyroid glands from the pork, from the pigs, dried them out. That means it was desiccated. It was dried out. And then they ground it up and they made Armour thyroid. So people who didn't have thyroid, weren't producing thyroid hormones, they were given this medication because you can't live for very long without having thyroid hormone. Now, another really interesting one that your book talks about is using the venom from the cone snail from the Philippines. This creates a drug, ziconotide, which is Prialt, and that's used for severe chronic pain. So down here I have an image of a cone snail. Kind of interesting little thing. I love the trivia. Now, when it comes to minerals, that makes a little bit more sense. We're a little bit more familiar with some of these drugs, including potassium chloride. The elemental symbol for potassium is K, so a lot of times the drug is going to start with a K. This is called chlorcon. And then we use that when there's low levels of potassium in the blood. And then things like zinc. Zinc lozenges, they're available over the counter. They're used to help treat the common cold, as we see here on this component. Now, chlorcon, we see right here where it says RX only. So this is a medication, but this zinc cold relief is sold over the counter, and this is actually a nutritional supplement. And that says homeopathic down at the bottom of that label. Anything that's homeopathic is a nutritional supplement, and we'll talk a little bit more about that in a few more slides. Now, those were the main ways that we made medicines in the past. We still do today from some of those, but where we are today is with drugs that are derived from manipulation. So it's either going to be molecular manipulation or genetic manipulation. So in molecular manipulation, we're going to change the chemical molecule of the drug. We can do this now with computer-aided design. In the old days, they had to do experiments, but now we've got computers that can alter it for us. Now, one of the things about this, changing the way that the structure appears, is called an isomer. So some of you may have taken chemistry or may take chemistry in the future. You'll learn about isomers. We do have some medications where we've taken it and we've just kind of twisted it a little bit, and we get what's called a mirror isomer. And what it does is you're looking at it in the mirror, so things are actually what was left is now right kind of thing. And we identify these by using location designators. So amphetamine is the first drug, and then we have a right isomer. Dextro means right. So dextroamphetamine. So they're basically the same fundamental compound, but we've just changed the way that it works by altering the way that that chemical molecular structure is aligned. Now, another one, ofloxacin, this is an antibiotic, and levofloxacin, and levo means left. Now, we do have some trans isomers. Your book talks about that, and it's talking about a chemo drug. We're not going to go all into that. But I did want to show you this image of how things are slightly different when we look at how we chemically can engineer a drug. Now, chemically engineered is also sometimes referred to as synthetic because we're making it in the lab. It's not coming from one of those natural sources. Now, in addition to isomers, we can just change the way that there are functional groups on a molecular structure. So when we look at these, they basically look very similar. We've got the same shapes going on. We've got the same ions, or not ions, but bonds happening here. We've got the nitrogen in the same place. But when we look over here, we've got this CH3 over here, and that's chlorodiazepoxide. Now, this was the first benzodiazepine. Well, then they chemically changed it around, and they moved this group over to this nitrogen. So they moved it over here, and they added another oxygen. Now it's the drug diazepam. That's known as Valium. So chlorodiazepoxide is known as Librium, diazepam is Valium. Both of these drugs are still used today. But it's just the changing of one functional group on a molecule that can change the way that the drug will work. Outcome, basically similar, but you're going to have some different components to it. So to me, it's quite interesting. Now, when we get down to the genetics, now we're getting into pharmacogenetics. This is where we've really come out in the last 30 years, manipulating the way the genes are and what we're making. So pharmacogenetics is the knowledge of how a genetic makeup of different people affects their response to the drug. People do respond differently. Men can respond differently than women. People who are overweight versus people who are underweight, children versus geriatric versus adults, different components of our genetics. We even know that in certain cases, race, the genetics associated with that could affect the way a medication works for a specific race. Personal human genomes are used to customize a drug treatment that matches the patient's genetic profile. In the future, as we continue to go forward with this, we get what's known as a targeted therapy. So it's going to be more patient-specific. Now, one of the things, and this is the earliest genetic manipulation, is a recombinant DNA technology, or what we know is an rDNA technology. So it uses an enzyme, and then it cuts apart segments of the DNA, and then they get transferred into a host who then can reproduce that. So the first one that we did that with was human insulin. So insulin itself originally came from animals. It came from pork, and it came from beef, pigs and cows. And then that was in 1922 that they discovered insulin. But in 1982, they discovered this recombinant DNA technology and were able to produce human insulin. So they actually use bacteria to create this. They give them the DNA sequence, and they're able to secrete the insulin. So this is what we use today. It also helps us regulate and control the dosing much better than trying to get it from animals. Other things that we'd use recombinant DNA therapy, erythropoietins, human growth factors, clotting factors. It's really quite amazing. We call many of these drugs bioengineered drugs. Now, monoclonal antibody drugs, they were first created in the mid-1980s. And one of the things when we're learning about these are what we know as immunomodulators, because they're helping with antibodies. So they're going to fight against something for our body. It's a monoclonal, which means it's one colony antibody. And I've capitalized the M, the A, and the B because your drugs that fall into a monoclonal antibody class will end in MAB. So we use that to help us identify. We can use monoclonal antibodies to treat autoimmune disorders, psoriasis, rheumatoid arthritis, or treat cancers, or we're actually using them also to treat COVID. Now, in gene replacement therapy, it's creating a person's missing or non-functional gene in a laboratory. So this truly is a completely bioengineered drug. The gene can be inserted into a virus that does not cause a disease in humans, and then that virus could be administered intravenously, and it will carry that new gene to the nucleus of the cell and make the patient's non-functioning cells work. That's pretty science fiction. It's pretty cool. Okay, now this is getting into the component of actually starting to learn about pharmacology, drug names. So we need to understand the different names that drugs are available by. Now, when we're talking about drug names, there's actually 3 different types of names that a drug could have. The first is their chemical name. Now, we're rarely going to use a chemical name because it's often complex. There can be 12 different versions depending on how they start naming the molecule, what functional group they're starting with. Is it an N? Is it cis? Is it para? What is it? It's complicated. It's confusing unless you take chemistry. Don't worry about that. We're not going to call most things by their chemical name. Now, the generic name is the common name. It's non-proprietary. And then the trade name is meant to be memorable, generally. It's also known as the brand name or the proprietary name. Somebody owns that name. They have a copyright. They have that little symbol, that R, trademarked, copyright. Somebody owns it. Now, coming back to the generic name, the thing about generic names, healthcare professionals are going to use the generic names. Every single drug will have a generic name. Not every drug has a trade name. Some of the older drugs that are on the market are no longer produced by a trade name. They're only available as a generic. Now, when it talks about saving money and we're in a pharmacy, we often will go with a generic name because it's usually less expensive than a trade name, right? Think about shoes or sneakers, right? If I say sneaker, you probably all have a different vision in your head. But if I say Nike, you're probably all going to see at least the swoosh, right? So if you just go into a store and get a sneaker, it could be anything. It could be any kind of tenny. It could look like a Ked. It could look like a Converse. It doesn't have to be a brand name. They're going to be much more less expensive than buying Nikes. So trade names, usually more expensive. But again, it's very memorable. When I say Nike, you see the swoosh. But you can't go buy a pair of those generic no-name sneakers, draw a swoosh on it, and then sell it like a Nike. You'd get in trouble. Now, when it comes to the FDA approval of drugs, the company who owns the development of the drug, they're the ones who pick the generic name, but it's got to be approved. It's got to be approved by the United Naming Council and the FDA. But then they also get to pick the first brand name or trade name of that drug. And they get a certain amount of time where they can market that drug and make money on it. The patent on that is 20 years. So we'll talk more about that a little bit later. But part of that is, I think it's in chapter 2, we're going to talk about the whole process of drug research and clinical trials and all the time and effort that goes into that. So when companies are preparing to market a drug, it takes a long time. They got to pay a lot of people. They've got a lot of bills, keep the lights on, doing the lab equipment, all that kind of stuff. So they need to make their money back. So that's why they have 20 years after it, but it does include some of that clinical trial time. But they're going to be the only one who can sell that drug for that period of time. Now, let's see. I'm going to put up an image of a chemical structure. Let's see. Can you identify this drug? Probably not, right? So again, if you know chemistry, well, maybe you could name this drug. But one of the names of this drug, we've got a chemical name, we've got the generic name and the trade name. We're going to start with a chemical name. So the chemical name of this is N-acetyl-para-aminophenol. Did I blow your mind yet? That's kind of complex. Who's going to walk in and say, I need some N-acetyl-para-aminophenol? Nobody, right? But the generic name of this drug, I bet you all have heard of. It's acetaminophen. All right. Now, when we look at this, the generic name actually has part of the chemical name in it, right? We've got acetaminophen, right? So they took part of that chemical name and made the generic name, but they shortened it down. So acetaminophen. Now, I guess that you would probably know that the trade name of acetaminophen, whoops, I wasn't paying attention to my slide. We're going to go to the trade name in just a minute. I'm coming back here to the chemical name. Now, I've highlighted the A, the P, the A, and the P. So APAP is actually a chemical abbreviation for acetaminophen. So sometimes we'll see that on a drug order. Because do we want the doctor to have to write out acetaminophen every time they have a combination drug that has acetaminophen in it? There's a handful. No, they'll just write the drug /APAP so that we know it's also got acetaminophen in it. All right, back on track here. So trade name, Tylenol. Now, what I want you to notice, it's here on the label, and I have it here next to the brand name. You've got that trademark symbol, that copyright. So when you're looking for a brand name, you're going to see the brand names usually very prominent, and the generic name always has to be listed on a bottle. Now, if it was a generic product, it would only have one drug name on it, because every drug has a generic name, but not every drug has a trade name. All right, so in your book, it talks about the generic names and how we identify them and when we're writing them. So this comes from a table out of your chapter 1. We're seeing the generic name here, atenolol. In generic names, the first letter is lowercase. The brand name, atenolol, the brand name is tenormin. For the trade name or brand name, the first letter is capitalized. So that's going to help us identify. And yes, I will ask you questions throughout this course. When I give you a drug name, can you tell me if that's a trade or generic? You're going to be looking. If it's lowercase, it's a generic. If it's uppercase, it's a trade. Now, the other thing that we're seeing here is some of these drugs have XL and LA. Those are extended release. Those are a special component. We can't just substitute. Now, I look at metoprolol. That's a whole other thing. When we get to the cardiovascular system, we'll talk about that. There's actually 2 different metoprolols. Now, when we look at this, metoprolol, it's giving us pronunciation guides. Atenolol, nadolol, propranolol. Now, all of these are beta blockers, and beta blockers end in OLOL. So, identifying the group that the drug falls into, that's called a classification, we can sometimes use part of that drug name to help us identify the drug class. Once we do that, we then know kind of some things about the drug. So, we call these drug stems. Now, a drug stem could be in a prefix, like sulfa and sulfamethoxazole, or it could be in infix. That means that the word part is in the middle, like pred is in the middle of methylprednisolone, or it could be at the end, a suffix, silin, like amoxicillin. So any drug that ends in silin is going to be related to penicillin. Drugs that start with sulfa are going to be related to sulfonamides. This helps us. If somebody is allergic to a drug in this class, it gives us a little heads up. It helps us identify. Now, trade names and the stories they tell. So in your book, it gives you a lot of information. Be sure that you review that information. because it can indicate what disease or symptoms of the drug that the medication is used to treat. So my favorite is saying Gas X, right? As a trade name. If something's named Gas X, well, what do you use it for? Ooh, I have gas. Easy to identify, right? Sometimes it can help us identify the body part that's being treated. So if I'm using something that's transdermal, it may have trans or derm in the drug name, like excuse me, like a patch. Nitroderm, that would be nitroglycerin that's going through the skin. Now, some drugs are going to help identify the generic name. A great example of that is the trade name Cipro is the generic name ciprofloxacin. So we're seeing that, oh, we just took part of the brand name or part of the generic name and made that the trade name. Now, sometimes it can help identify ingredients that are in the drug, like ferrosequels. Ferrous is iron, so Fe is the elemental symbol, so that starts with ferro, Fe. Premarin, it talks about the pregnant mare's urine. Yeah, they extrapolate out from the urine of a pregnant mare and get the estrogen out. Now, using the trade name to help indicate the therapeutic effect. Glucotrol, it controls glucose. It's used for type 2 diabetes. Lipitor or Lopid, I like that one even better. Both of those lower cholesterol, they lower lipids. Lopid, lower lipids. Low pressor. On the previous slide with the drugs out of your textbook, metoprolol, one of those was low pressure. It lowers blood pressure. So there's a lot of things in there that can help you identify, well, what are we using it for? Now, another is to indicate how often we're going to take a drug. So the trade name can tell us. Something like lithobid. Anything that ends in BID means twice a day. So lithobid is twice a day. Nitrobid would be twice a day. That can help us identify how often to take it. Another trade name indicator is how long will the drug last. So again, on that previous list, I was pointing out the LA and the XL. There's CD, there's SA, there's SR, sustained release, extended length. That's going to tell us, hey, these are going to work longer. The trade name can help us indicate the strength of the drug. Cortisone 5, it's 5% or 0.5% actually hydrocortisone. It's helping us identify the cortisone 10, or your book gives the example of Bactrim DS, which means double strength. So there's a single strength that's a combination drug, and then there's a double strength. So they don't even put what is the strength on there because there's only those two strengths. It's either single or double. And one of the other things that a trade name can tell us is the route that it's being administered. So again, I'm going back to that dermal, transderm scop. If you've ever been on a cruise, maybe you got that little round patch you put behind your ear so you didn't feel motion sickness. That's scopolamine, but it's in a transdermal patch, transderm scop. Nasonex. It's going in your nose. Nasal, nose. So there's something in a lot of the drug names. Now, does it always work? No. Sometimes it's just made up names that the drug company has come up with. They can be hard because they don't have to follow any kind of spelling rules. They can mix up the vowels and the consonants whatever way they want and then tell us what it sounds like. But these are some of the things that we can get from some of the drug names. The more you can associate, the easier it is to learn. Then you only have to learn the exceptions. Okay, so next we're going to talk about the types of drugs. This is about availability and how drugs become available. So when we're talking about the types of drugs, basically there's prescription drugs and there's over-the-counter drugs. So a prescription drug is also known as a legend drug. There was legislation called the Durham-Humphrey Amendment that designated if you need a prescription for the drug or you can buy it without a prescription. So an over-the-counter drug is a drug you can purchase without a prescription. Now, another type of drug is a scheduled drug. These are controlled substances. These are considered to be dangerous drugs. Most scheduled drugs are prescription. There are a few exceptions. So some scheduled drugs can actually be purchased over the counter. So it can get a little hazy there. But if we're really talking about availability, it's going to be prescription or it's going to be over the counter. Then we look at some of these subgroupings of that. Now, the prescription drug, it's called a legend drug. And in the old days, it had this statement on the label that said, caution, federal law prohibits dispensing without a prescription. But then we had a Modernization Act that says, okay, the bottle has to say RX only. That's what that means. It means you have to have a prescription. So that made it much easier. Now, the RX symbol, as we see here in this big circle, it actually is part of the prescription. And on the prescription, it has a meaning. It means, it's Latin symbol for recipere, like recipe, right? It means to take or receive. So when we're transcribing the information for a patient, we generally, before we start telling them what they're taking, we tell them, take 1 tablet by mouth, type of thing. But that's what it's just to kind of get the ball rolling. Now, over-the-counter drugs, the manufacturer of a prescription drug can ask the FDA to change the status of to over-the-counter. The topical drug hydrocortisone was the first prescription drug available for over-the-counter sales. Well, technically, I don't know. Aspirin's been over-the-counter for a really long time. And I think that's because it was one of the first drugs and it actually was manufactured in 1899. So it's been around for a really long time. But hydrocortisone was approved for over-the-counter sales and then other drugs followed. It has to, the original drug as a prescription drug, but most of the time it's going to be a lower dose. It's not going to be as high of a dose that the prescription drug might want. The Over-the-Counter Drug Advisory Committee assists the FDA in reviewing prescription drugs, and it determines which ones are safe and appropriate for over-the-counter use. Basically, they want to look at specific criteria, make sure that, the indication is the same, the patient can easily diagnose and monitor his or her own condition when using the drug, and when the over-the-counter drug has a low rate of side effects or toxicity, and a low potential for abuse, and the use of the over-the-counter drug does not require the patient to have any special monitoring or undergoing any special laboratory tests. So all of these 4 things have to be considered before a drug is available over the counter. So when we look at it, here's an example. Now, sometimes when things become over the counter, they actually will identify it. So Prilosec can still be sold by prescription, but this one is available OTC or over the counter. Now, in 2005, there was the Combat Methamphetamine Epidemic Act. And that required that certain things be restricted. So they don't require a prescription, so technically they're over the counter, but they're not out front. So when we look at a pharmacy, we have the front of the house and then you have the behind the counter. So drugs that contain pseudoephedrine or ephedrine are sold from behind the counter. You have to show an ID. You can only purchase a certain amount within a certain time period. There's some restrictions on that, so it's considered a restricted drug, but you do not require a prescription. So in that regard, it is still considered to be over the counter. Now moving into the scheduled drugs. So the Comprehensive Drug Abuse Prevention and Control Act of 1970, this is where we've got the schedules of controlled drugs. Before controlled drugs, they didn't exist. They were just prescription medications. Now, what this did was also created the Drug Enforcement Administration, the DEA, which is a judicial body. They regulate manufacturing and dispensing of these drugs. These drugs are still all approved by the FDA, but once they're deemed to be dangerous, potential for abuse, they can fall under this schedule category. Now, there are 5 schedules. So Schedule 1 is not something we're going to have access to. That has no medical use, has a very high potential for abuse and addiction. Prescription drugs start at Schedule 2s. Schedule 2s are approved for medical use. They have a high potential for abuse and addiction. And because of that, there are no refills. So morphine falls into the category, oxycodone, Percocet, Norco. You may have heard of some of these things. Even fentanyl is in that Schedule 2 group. Now, Schedule 3 has less potential for abuse and addiction than Schedule 2. So that would be like Tylenol number 3. It would be things like anabolic steroids. Testosterone falls into that group. Marinol. Then we have Schedule 4s. We're going less and less down that abuse and addiction potential. So a Schedule 4 has less potential. That's your benzodiazepines. That's Ambien. That's Valium. Those types of drugs. And then Schedule 5 has limited potential for abuse. Most of these are combination drugs. Phenergan with codeine, Tylenol with codeine, Elixir, the liquid kind, not the tablet. The tablet would be a C3, but the liquid is a C5. Even some diarrhea medicine, Lamodal, would fall into the C5 category. Most of these will require a prescription, but even technically by law, Phenergan with codeine doesn't require a prescription. Chances are a pharmacist won't sell it to you without a prescription, but technically by law, it doesn't require one. Pharmacists do have right to refuse. Now let's look at these. Now on every package of a controlled substance, it has to have the controlled substance symbol. So that's a C for controlled substance, and it's got a Roman numeral inside that tells you what schedule it is. So here we've got meperidine. This is the generic name. See, it's only got one name on the bottle. Now the hydrochloride, we're not really worried about that. That's just part of the salt. So meperidine, the brand name for that is Demerol. Now we're also going to talk about in, I want to say chapter 2, or maybe it was 3, that we're going to talk about the dose information. So we'll come back and visit this again. Over here we have phenobarbital. This is a barbiturate. It's got barb in there, so it's helping us identify the class. This is a control schedule 4. So this one can have some refills. This one cannot. Over here we have Lyrica, which is pregabalin. This is a control schedule 5. People use Lyrica for neuropathic pain. Now, one of the things with controlled substances, when we dispense a prescription to a patient, it has to have a transfer warning. So not only are we seeing on here that RX only information, but a transfer warning is caution, federal law prohibits the transfer of this drug to any person other than to whom it was prescribed. So if somebody has a prescription bottle for someone else and they're found in possession of it, they could actually be arrested. So only the person whose name is on the bottle should be in possession of that bottle. Now, when we talk about controlled substances, inevitably medical marijuana wants to come up as a topic of conversation. So it is considered to be a federally restricted C1, which said no medical use. But the federal government's kind of backed off and left it to the states to decide. So 33 states, including Louisiana and Washington, D.C., have approved marijuana and CBD products for medicinal purposes. Now, there are certain conditions that have to be met. In the state of Louisiana, the Board of Pharmacy oversees the medical marijuana dispensaries. It's run by a pharmacist. Pharmacists work there, technicians work there. So it's not like other states that have dispensaries that you can just walk in off the street, like Colorado. They have it for recreational purposes. Now be cautious, because just because you have a card and you have one of these conditions that's deemed eligible for treatment does not mean your employer has to recognize that. So some people get a little, well, the government and the law says it's okay, but your employer can still say it's not, okay? Alcohol is legal, but you cannot show up to work drunk. Alcohol will clear your system. Marijuana will stay behind. So if they do a drug test, it will be, if they do hair, if they do other things, it can show up. Just kind of a heads up on that. Now, some of the different things that we can treat with CBD. First off, what is CBD? CBD is a cannabinoid. That's the part that reduces pain and inflammation. Now, marijuana as the plant, if somebody's smoking it, it also has THC. THC is tetrahydrocannabinol, and it's a psychoactive component. So that's where the high comes out, where the CBD is more about the pain and inflammation side of it. So we use it for conditions such as migraine headaches, pain, muscle spasticity, Parkinson's disease, glaucoma, nausea and vomiting associated with chemotherapy, and also body wasting diseases because it does stimulate appetite. So there are considered to be medical uses for marijuana. So here is an image of Marinol, which is dronabinol. So this drug is actually a derivative of the CBD. So it's a synthetic version, and we actually use this for nausea and vomiting associated with chemo, but also to stimulate appetite. So if somebody's got cancer or they have HIV or something like that and they have no appetite, they could also use this drug. And we see here, okay, Marinol is the brand name. We see that trademark symbol here. Dronabinol underneath, that's the generic name. Yes, I know both are all caps, but it is smaller and it's underneath. That tells us as generic name has to be on every single bottle. But if you own it, you want your name biggest, right? It's McDonald's hamburgers. Right? McDonald's is big, the hamburgers are small. And you can see that it's a controlled substance. It's a C3. So it's a control schedule 3. Okay, just a couple more slides to go and we're through this chapter 1. So the next thing to talk about are dietary supplements. So in 1994, the Dietary Supplement and Health Education Act, or the DSHE, was passed. And what it did was it identified things that are considered dietary supplements. Vitamins, minerals that aren't prescription like iron or potassium chloride, herbals or plant-based substances, amino acids, and then concentrate, metabolites, constituents, or extracts of these components, these natural components. These generally are going to be homeopathic, the concentrate and constituents. Those are going to be homeopathic. Homeopathic, again, like I said earlier, is considered to be a dietary supplement. Now, these are considered to be food products. These are not medicines. So they're going to have the way that their information, it's going to be more like the label on a food product than it is medication. Now, I know because this one doesn't have it. It says cold zinc relief, and you don't see anywhere on here where it says dietary supplement. But again, it says homeopathic. So that means it's not a prescription drug. And if it doesn't fall into those categories, it's not really an over-the-counter. It's a dietary supplement. But up here we see very clearly these soft gels are dietary supplements. And over here with the Remifin, black cohosh, an herbal supplement. So herbs, those are considered dietary supplements as well. All right. So the last couple of types of drugs that Chapter 1 talks about are orphan drugs and designer drugs. Orphan drugs are described as drugs that treat rare diseases that affect fewer than 200,000 people in the U.S. So normally these drug companies aren't going to spend a lot of money developing these drugs. They don't have the time or the money. They're not going to make it back. So the Orphan Drug Act of 1983 wanted to incentivize these manufacturers. So they give them special tax breaks. They give them special length on their patents. So they have more time to earn money back. And they're getting tax breaks. So the Orphan Drug Act is really for the benefit of people who could die from diseases because nobody's going to invest in money to try to cure them, or if not cure them, at least treat them. Now, when it comes to designer drugs, these are illegal drugs. They're produced and have chemical structures that are going to be similar to your C1s and your C2 drugs. These are considered to be analogs. So this is stuff that we find on the street. This is not medication that we're going to have in a pharmacy. So that wraps up the content from chapter 1. A few more questions for you.